So partial fractions, essentially, if I have something like this, 6 over, and let's say x minus 1, x plus 1, bracket, bracket, x plus 2. That is a mess. And if you had to find the integral of that, that would be very hard, right?
Yeah.
Because we were looking earlier and we could do the integrals of things with, we had a whole topic, which was our last topic, which was all about the integrals of things with quadratics on the bottom. But now we've got a cubic on the bottom. So that's going to be very hard for us to do. So what we'd like to do is split this up into smaller fractions that we can deal with, right?
Mm-hmm.
So we can do that by, let's say I have a constant value a, and I have a constant value b over x plus 1, and I have a constant value c. So partial fractions is essentially, we want to find the values of a, b, and c that let us go from here over to this side.
Right.
So that's what we're trying to do. We're trying to go from this side here to the point where we split them up into some nice manageable fractions. And yep.
Sorry, it's just I have a theory in mind. If we wanted to have an a over x minus 1, would that mean we'd have to times the numerator by x plus 1, x plus 2?
Perfect. So from here, when we're trying to solve this, we have to let them equal and say we've got some value of a, b, c where this is true, this works. And now we have to find them. So what do we need to solve 3 equations? Sorry, what do we need to solve 3 variables? We need 3 equations, right?
Yeah.
Yeah, just like with simultaneous equations, we need 2. So for this, we need 3.
Mm.
So we get that by multiplying.
Yeah.
And like you said, so my top will become a bracket x plus 1 bracket x plus 2. And then what will be plus b? What will be my b?
X minus 1 and x plus 2.
Yep. X minus 1, x plus 2. And what about c?
X minus 1, x plus 1.
X minus 1, sorry. X plus 1. All over x minus 1, x plus 1, x plus 2. And these are equal, right, to that?
Yeah.
So now, where do I get my 3 equations from? Well, let's first expand out this top section a bit more. So we'll get a bracket x squared plus 3x plus 2 plus b bracket x squared minus plus x minus 2 plus c outside of x squared minus 1 all over x minus 1, x plus 1, x plus 2, right?
Yeah.
So from here, what we're going to do is we want 3 equations. So what we're going to do is we're going to equate our coefficients. So here, if I were to expand this out, then I'd have ax squared plus 3ax plus 2a, and same thing for my b and my c. And I know that this whole top section should equal to 6. So what is my coefficient of x squared? What should that be equal to?
No. Sorry, what?
So over here, I'll have x squared terms and x terms and constant terms. But from this side over here, what's my coefficient of x squared?
0.
0. And what about x?
0.
Yeah. So that means I'm going to have a x squared plus bx squared plus cx squared equals to 0x squared, which means that a plus b plus c is equal to 0.
Yeah.
So that's one equation.
And then 3ax plus bx plus just 0c.
Yeah. So that if I then get rid of my x's there, that'll give me 3a plus b equals to 0.
Mm-hmm.
So that is a second equation I've got. And
then the third one would be 2a minus 2b minus c equals 6.
Equals to 6. Perfect. And so now I can use these to find my a, b's, and c's. This is equation 3. So from here,
So I'm guessing you're going to use 1 and 3 together first to find c. Or not c, but a or b.
I would probably start with 2, because then I can get b in terms of a and substitute that in here, and then I can get c in terms of a, and then I can substitute that all in here.
Oh, right.
Get an
I was going
equation.
through the other one where you subtract each value. So like 1 minus 3 kind of
Oh,
thing.
yes. Yeah, you could do that. I might
minus
just
1 in this case.
Yeah, I might just start with substitution. So let me just clear all of this because I will need some working out room and rewrite my equation. So I have a plus b plus c equals to 0, 3a plus b equals to 0, and then 2a minus 2b minus c equals to 6. That's 1, 2, 3. Right?
Mm-hmm.
So then from 2, I get, I won't actually put that there. From 2, I get b equals to minus 3a. So then I can substitute into 1, and that gives me a minus 3a equals to c, plus c equals to 0. So that gives me c is equal to 2a.
Mm-hmm.
So then substitute into 3. And let's say I call this 4 and 5, and I can say substitute 4 and 5 into 3. So then that gives me 2a is equal to 2a plus 6a minus 2a is equal to 6. So then that gives me 6a equals to 6, which gives me a is equal to 1.
Yeah.
Yep. And so if a is equal to 1, then I can...
We can put that back into 2.
Yeah.
That will be 3 plus b equals 0, so b is negative 3.
Yep, so b is equal to negative 3. You're right, because that goes into that, and that becomes 3, and then we minus 3 over. And then what do I put these two into? I put those two into 1.
Yeah.
So sub into 1. Sub into 1, and that gives me 1 minus 3 plus c equals to 0. So that gives me c is equal to 2. So from there, I'm going to have 6 over x minus 1 bracket x plus 1 bracket x plus 2 bracket equals to 1 over x minus 1 minus 3 over x plus 1 plus 2 over x plus 2. And that is much more manageable. Because if you look at that first one, if you were to try and take the integral of that, actually, if you were to try and take the integral of any of these, you could just pull out the constants and then use logs, right?
Yeah.
Yeah, so it'd be pretty easy.
So it will be ln of x minus 1 minus 3 ln of x plus 1 plus 2 ln of x plus 2.
Yeah. Exactly. Does that make sense?
Wow. Yeah.
Yeah, not that bad. But if you were to try and get that from this, you'd be there all day just trying to think about what's going on.
Mm.
But if we can simplify it to something nice and digestible, then it gets pretty easy.
Yeah.
So let's also think about, what if I had something like this? 4 over x minus 1 bracket x plus 1 squared. So I've got this squared term here now. I don't just have a bunch of linear terms to the power of 1. I've got a squared term. So what I'm going to do there is I'm going to go a over x minus 1 plus b over x plus 1 plus c over x plus 1 squared. So what I'm doing here, when you have a linear term with a square in the power, or any power, we go up to that power. So here I start with a power of 1, and then I got to a power of 2. If that was, let's just cross this out. If that was to the power of 3, let's say, then I would add d over x plus 1 to the power of 3. So you step up to it.
That makes sense, because you'd need an x and an x squared and an x cubed and an x to the 4.
Yeah,
So
exactly.
the more powers you add, the more kind of powers on the x you need to add on. So then you'd have to go one by one.
Yeah. You probably won't see any cubes though, because then you'd have to solve 4 equations at once, and that gets pretty messy because you don't have
Yeah.
the maths to solve a bunch of equations at once.
Mm.
At university, we'll learn some maths that makes that really easy. But
Okay.
up until then, we're just working with it. So you'll probably only see up to a squared, because even then you've still got to solve some pretty messy equations.
Mm.
But from there, we can just expand this out and then solve this using the same methods we were using earlier. Except now we should expect to get a cube term in there. So we should actually, yeah. No, so we should just be getting a squared term in there. Yeah, because if we look at our denominator, we're going to have, so if we want to get this, to that denominator, then we don't have to multiply by the x plus 1, we just have to multiply by the x plus 1 squared, right?
Yeah.
And then over here, we just have to multiply by x minus 1 and x plus 1. And over here, we just have to multiply by x minus 1.
Yeah.
So we won't actually be getting a cubic in the power, which means we still only get 3 equations. Does that make sense?
Yeah.
And then you just go through and solve it the same way we did, and then you're fine. So that's what happens when we have, this is called repeated linear factors in the denominator. And that name probably makes a decent amount of sense given what's going on, because here we're repeating and iterating through with multiple linear factors on the denominator. Awesome. So what if they weren't linear? What if I had, say, 5x plus 2 all over x minus 1 bracket x squared plus 2x plus 4? What if I had something like that?
So we do the perfect square kind of thing?
Not quite. Because if you have a look, I don't believe that actually factorizes. Because if we have a 2, the factors of 4 are 1 and 4 and 2 and 2, and we can actually get that down to 2.
Yeah.
And bringing something into this fraction to try and fix that up is going to be tricky because we're also multiplying it by x minus 1.
True.
So we're going to use partial fractions again to try and split this up, but when we're splitting it up, we're going to be doing something a little bit different. So here I'll have, say, a over x minus 1, but then I'm going to use plus b x plus c over x squared plus 2x plus 4. And this is because when I have a quadratic factor on the bottom, I need a linear factor on top.
Yeah.
When I split it up. So you can think of it as you're using the derivative of whatever kind of function this is on the top. So here, if this is quadratic, I have to use linear. And since this is linear, I have to use a constant.
Right.
Yeah. So you can think of it that way. But then if I were to expand this out, then that would become a outside of x squared plus 2x plus 4 plus bx plus c bracket 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 x minus 1 all over bracket x minus 1 x squared plus 2x plus 4, and then that equals to ax squared plus 2ax plus 4a plus bx squared minus bx plus cx minus c all over x minus 1 bracket x squared plus 2x plus 4. Now importantly here, my quadratic factors, so a plus b, they're still going to be 0 because I still have no quadratic on the top here, right?
Yeah.
And then, but my linear factors now, they're not going to be 0, they're going to be equal to 5. So here I have 2a in front of my x here. I have a minus bx and a plus c here, so it's going to be minus b plus c, and they're going to be equal to 5. And then I have a 4a minus c equals 2. And from here, I can solve.
Yeah.
So this one's actually not going to be too bad, because here I know that b is equal to minus a, and from here I know that c
2a plus a.
2a plus a.
Yeah. Oh, if a plus b is 0, then b is negative a, then wouldn't you put it into the second equation?
Yes, but let's look at the third equation first, because if I go here, then I know that c is equal to 4a minus 2.
Oh, yeah.
And I can take this and sub it into there, and I can take that and sub it into there, which gives me one equation just in terms of a. So then I can find my a and sub that into my first and my third to get my b and my c.
All right.
Does that make sense?
Yeah, so it'll be 2a plus a plus 4a minus 2 equals 5.
2a plus a minus 4.
Plus 4a.
Plus 4a minus 2 equals to 5. So then from here, 7a equals to 7.
A equals to 1.
A equals to 1. And so from there, that means that c is equal to 2, and b is
equal to negative 1.
Negative 1, exactly.
Right.
So that means that my equation, I'll just rub all this out. My final equation is going to be 5x plus 2 all over x minus 1 equals, bracket, x squared plus 2x plus 4 bracket is equal to 1 on x minus 1 plus minus x plus 2 all over x squared plus 2x plus 4. And so it works.
Yeah.
Yeah, does that make sense?
Yeah.
So no real dramas there, and you're done. That's that found, and then we can use logs here and logs here to find the integral.
Hmm.
Does that make sense?
Yeah.
Now, importantly, we can also, before we had repeated linear factors, we can also have repeated quadratic factors if I were to square or cube that, at which point I would then have to add another term where it's, say, ABC and dx plus e all over x squared plus 2x plus 4 squared. And I can do that as well, which I realize would be annoying and rather time consuming, but you can get questions like that. Although you will normally see them in terms of, let's say it's 1 on, it'll be something like 1 on x bracket x squared plus 1 squared. So it'll be a
Right.
simpler quadratic rather than something like this, because that could be very annoying.
Yeah, that would be like 1 on x, or a on x, sorry,
Plus bx
bx
plus,
to c, or x squared plus 1, and then dx plus e over x squared plus 1 squared.
over x squared plus 1 all squared. Perfect. Yeah.